Okay, so we're going to move on to 8.5 in your textbook. It's page 261, and the essential question is, how do you solve systems with no solutions or infinitely many solutions? So we have kind of discussed already this idea of parallel lines, intersecting lines, and then two equations that create the same line. So they've given us the graph on the right, and they're asking us to recognize the line x plus y equals 7, which I've highlighted in pink, and then also recognize the yellow line, which is 2x plus 2y is equal to 6. So when you take a look at those two lines, they appear to be parallel. So the question is asking, is there a point of intersection? And we would say no, because they look like they are parallel lines, and parallel lines never touch. They don't have any points in common. So does this linear system have a solution? And we would say no, because parallel lines do not intersect, therefore there's no solution. Because remember, a solution is a point where two lines intersect and we can identify the x and the y where they touch. The next one is asking us about the line 2x plus y equals 6, which is the yellow line, and also x plus y, which is 3, which happens to also be the yellow line. So these are the same line. So is there a point of intersection? Well, in that case, we would say yes, there is a point of intersection. And that's because it is the same line. So not just one point of intersection, but all of the points intersect on that one line. So this has infinitely many solutions. The next question is asking us to identify two lines that represent a linear system with exactly one solution. So anytime we have two lines that intersect, we know that that is equal to one solution. So we could have wrote down the yellow line, and we could have wrote down the orange line because they intersect at this point here, or we could have written down the pink line and the orange line because they intersect there. So on the next page, we're going to continue the discussion. It says a system of linear equations has infinitely many solutions. Does that mean that any ordered pair in the coordinate plane is a solution? The answer to that would be no. All of the ordered pairs on the line are a solution, but that doesn't mean any point in the coordinate plane would be a solution. Number 3 says identify the 3 possible numbers of solution for a system of linear equation and explain when each type of that situation occurs. So you've got 3 possible solutions: no solution, infinitely many solutions, and one solution. So if we have parallel lines, we have no solution. If we happen to have the same line, it would be infinitely many. And if we have one solution, meaning 2 points or 2 lines intersect at one point, then we would have one solution. So example 1 is asking us to solve the system with substitution. So our first equation is x minus y is equal to -2, and the second equation is -x plus y is equal to 4. I'm choosing to get y by itself, so I'm going to add x to both sides, and then I have my equation y is equal to x plus 4. So inside my parentheses here, in place of y, I'm going to put the equation x plus 4. Now remember, the subtraction symbol is independent from the equation that I'm inserting for y. So I want to make sure I put parentheses around that because that's going to tell me that I need to distribute the negative to both of the terms on the inside of the parentheses. So this x is here, and then I distribute and I get a -x here, and then I distribute and I get a -4 here. -2 is fine, it's left alone. X minus x is equal to 0, so that means that term cancels. I'm left with -4 is equal to -2, and we know that -4 does not equal -2, so that's an example where there would be no solution. So if I were to graph these, they would end up being parallel lines on a coordinate plane.